So good afternoon, everybody. I'm Sanjay Chopra. I am the co-founder and CEO of Cognistx. So again, welcome to our webinar. And special thanks to Jag and Justin and Patty to put the webinar together along with Pete. So thank you. Thanks to the team for an awesome job. What we'll be doing today is, here is the agenda. I'll quickly kind of talk about the company overview. And we're really fortunate to have Dr. Eric Nyberg, my co-founder, join us. We will be going over a history and overview of information retrieval, search, question answering system, obviously the new fancy large language models that have been made very, very popular with ChatGPT. But there are a few others like Bard. And Eric will kind of talk about the historical perspective, talk about multi-strategy AI, both using extractive models and generative models. And we're going to be talking much more about these in a little bit. Also, personalization of language models, specifically to certain domains, whether it's legal or medical domain. And then talk about dynamic versus static question answers. If you already know the kind of questions people would be asking versus sort of ad hoc or dynamic queries, how to sort of cater to those things. We'll be doing use case analysis, talking about our framework to make QA systems and large language models really work for you. And then the team has put together a fantastic demo. So that's the plan for the afternoon. And at any time, if you have any questions, feel free to interrupt. You can post your questions in the chat bar, and we'd be sure to sort of, take care and answer those questions as soon as possible. So with that, I will quickly go through a company overview as people come in. We are now 8 years old. I guess time flies when you're having fun. We are a Carnegie Mellon spinoff. So Eric and I have actually known each other way too long. We actually were together at Carnegie Group back in the early 90s. That was another CMU spinoff with Raj Reddy and Jaime Carbonell and some fantastic, fantastic people. We actually also, where Eric helped us with Intellions, where we sold the IP and technology to Google. We are sort of, thanks to Eric and our data science team, we have leading AI experts in our team, specifically natural language processing and predictive analytics. We have about 30 people, a few patents, and we are growing. You can see at the bottom, a lot of Pittsburgh companies, global national companies that we worked over the past 8 years. A little bit more on my background. When it comes to background, I'm a little bit undereducated. I only have a couple of masters, some MBA from CMU and masters in computer science. Eric obviously got his PhD. He was the director of the computational data science program. I think he just gave that up. He was also one of the leading researchers behind IBM Watson and has been working in the area of NLP for a really, really long time. So that's a little bit of our background. With that, actually, I'm going to hand it over to Eric. Eric, if you could get started with the history and take it over from here.
All right. Thank you, Sanjay. So I think it's really important to put all of the sort of recent hype about ChatGPT and language models into an appropriate historical context. So if we go back in history and think about sort of the first programs that people wrote that tried to process, human text as opposed to, numeric data, we go back to sort of the post-war era, post-World War II era, where Gerard Salton and his colleagues sort of developed the basic concepts of information theory, which spawned something called information retrieval, which is essentially an approach to take a very large collection of documents and then search that set of documents very quickly for the most relevant documents. Obviously, you can't search every single word in every single document to find the key terms in your query. That would take far too long. So IR researchers realized you could prepare in advance by creating what's called an inverted index. So for every word that appears somewhere in your set of documents, you build a big table that tells you exactly where those words appear and at what positions they appear in those documents. Then at runtime, when somebody gives you a query, you can very quickly find the set of documents where the terms appear. You can sort of find the intersection of those documents, and then you can also find which portions of the documents contain the terms very closely together. So this allows you to sort of use this kind of matching as a proxy for relevance. And it works quite well if humans are giving you reasonable key-term queries. Of course, Google is the example that we all think of when we think about information retrieval. The big addition that they made to the inverted index was to use the idea of popularity of a web page to also inform this relevance decision. And this isn't pretty easy to do. If you look at all of the documents on the web, you can actually compute how many pages refer to a particular page. So a page that I wrote on my website is not going to be as popular as, let's say, the Wikipedia page for the United States, which is probably referred to by millions of other, web pages on the web. So Google got ahead of the pack and started processing the entire web using this kind of metric. And that's why they still have sort of the best, basic search algorithm out there for large sets of documents. But what if we don't want to use a key term query? What if we'd actually like to just ask our question in fully formed English the way we would ask our question to our assistant, who was going to go off and search the answer for us? So starting in the 70s, we began to have research on how to process natural language questions and figure out what kind of answer type the user was looking for. Do they want documents? Do they want passages from documents? Do they want sentences? Do they want to find the actual name of an entity? Where was Elvis Presley born? Do they want a number? The current population of Pittsburgh. So it's much more than just finding the documents that are more relevant. You have to also do what's called answer pinpointing, which means you have to find the actual piece of text that contains the answer rather than just returning, what you think is the most relevant piece of text. So this has been researched, like I said, since the early 70s. Earliest applications were things like using natural language questions to access information in relational databases. So when I started working on QA in the middle 80s, we basically built a system where an executive could ask questions which would be translated into SQL queries, which would then be executed against the database, to bring back information about, customer billing and things like that. Nowadays, this is fairly ubiquitous in the IT world, but back then it was sort of the first step in being able to do QA. Now, since 2018, things have gotten exciting. So obviously, I want to point out to you that large language models have only been around for about 5 years, which is a tiny fraction of the amount of time that these other disciplines have existed. So an obvious question to ask is, well, are large language models good enough to basically eliminate a need for any of that other technology? Are they really that good? And I think that's one of the things that we're going to explore here today. So a large language model is very interesting. The idea behind this is that you don't want to look up any documents at runtime. You basically want to read all of the documents in advance and then try to remember them. Not necessarily, the way a brain might remember them, but you want to remember them in such a way that if somebody asks you a question, you can literally generate the answer from your own memory. And this, of course, is a memory that's built up from all of the documents that you've read as a statistical learning model. So an LLM is essentially a statistical model that can produce some string of text that is most likely to contain the answer to the user's question, given the content of the text corpora that the model was trained on. So that's really important. And I can give you an example of where things like this fail. An early version of ChatGPT was asked the question, what does John Smith do at the Language Technologies Institute? And in response to that question, ChatGPT crafted this beautiful paragraph which explained what kind of professor John Smith was, what kind of research he did, what papers he had published, and then what awards he had won. The only problem with it, and it was beautiful. I mean, you couldn't have written a better bio yourself for John Smith's website. The only problem was that John Smith is not a faculty member at the Language Technologies Institute, nor has he ever been. We also asked ChatGPT about a person who was at the Language Technologies Institute, and it gave a pretty good paragraph, except it made a couple of mistakes. It said this person had won a Best Paper Award at some conference where they hadn't. And if that person, or let's say a person, building a website for that faculty member had used that paragraph on the faculty member's website, they could get in trouble for basically claiming that they had received an award that they hadn't. So what's very interesting about these models, which was mentioned on Sanjay's earlier slide, it's kind of a roll-up for you guys, to take away later, is that large language models like ChatGPT are super fluent. They sound so good that you want to believe that they're correct. Extractive QA, old-fashioned QA, can kind of find the answer, and maybe it will show you the original paragraph, but it's not really capable of generating such fluent responses as a model that's been trained on billions and billions and billions of sentences. So the question is, what are the mistakes that are made here? Let's dig into that a little bit more as we go along here, because as business users of question answering, we really got to decide, what balance of technologies we need to use. So the old-fashioned technology, or at least, before 2018, we can think of as extractive, has big advantages because you index all the documents and you know exactly where you extracted the answers. You can actually give the user your answer, and you can show them exactly where you got that answer from. It's easy for you to give a confidence score in your answer because you can build a model based on how many times you found the answer and what sources. Very easy, to provide an estimate of the quality of the answer. These answers are very interpretable and explainable because if you ask the system, hey, where did you get that answer? It can literally bring you right to the documents where it found the information, and you can decide for yourself whether the answer is accurate. And you sort of then can avoid questions that arise about large models with respect to bias and controversy. When models are trained on very large sets of documents, which themselves have some inherent bias, maybe in all of the newspaper stories, the majority of the men who were mentioned or the medical doctors who were mentioned happen to be men, a statistical language model would assume that, hey, if it's a doctor, I should always guess that it's a man because of what I've learned. So large language models don't have the ability to learn real common sense principles the way that humans do. They just learn what they're given to read. So if there's some kind of inherent bias in the documents, the language model will incorporate that bias. And that's one way that errors can arise with these large models. Extractive models are dependent on the quality of the information. They're not very creative. They're not very good at generating longer paragraphs the way that large language models are. And they can't generate where there isn't a document to retrieve from. The generative models, on the other hand, basically have the ability to do very creative generation of answers, and they will always do the best job that they can, even if you give them an incomplete or partial input, and they are much more fluent than extractive systems. They sound very plausible. The limitations, as I already mentioned, are that they generate incorrect or sometimes nonsensical content. And because of that, you kind of have difficulty in controlling, what they put out. So a lot of research now is actually focused on how to use something like ChatGPT and then post-process what it produces to basically identify maybe where some of these errors are likely to be lurking. We already talked a little bit about bias. There's no way for you to check the source. So in that example that I gave you about the fictitious language technologies professor, we asked ChatGPT, why do you think John Smith is a professor at the Language Technologies Institute? And it couldn't give an answer. In fact, at that time, ChatGPT didn't even know how to respond to this kind of meta request. And it just kept talking about John Smith, basically a repeat of what it had said earlier. Also, large language models really require a lot of data. The reason why they're so interesting to everybody right now is that there are very few places on Earth that have the resources to process this large amount of data to build a model like this. So we're kind of left to probing them and figuring out what they can do. And in general, if you want to apply these technologies in your business, one of the first questions that we would ask you is about the magnitude of the data that you have to work with. In some technical domains, you don't have enough information to train a sophisticated statistical model like ChatGPT. So it can't work in every domain. It really is very data hungry. Okay, so now that I've kind of motivated the idea that we want to balance the earlier technology with the newer technology for practical applications for business value, let's take a look at sort of how we would build a multi-strategy solution at Cognistx. So the first thing we do with you is take a couple of weeks to explore how you want to use the technology. What kinds of queries are you asking? What kinds of data are you drawing from for your answers? How would you define success? Do you have specific ideas of how accurate the system has to be? How many questions it can answer, on average, that kind of thing. Then we get into a discussion about what documents or other resources are required to build a system. And then essentially we do a bunch of benchmarking of all of the available language models. And then we decide, which of those are relevant for the task at hand. And then we can integrate those with our existing extractive technology that we've already built. And then create this combined architecture, which we evaluate against customer data. And then it usually takes a couple of months to do evaluations with a customer where we set up an instance of the service. You start pounding on it with some early adopters. We see what mistakes are going on, and then we're ready to go live. So the idea is that we have a sort of nominal 3-month window where we can work with you and then sort of determine, what technologies are really the best for your problem. Jag, do you want to take this one, or Ihor, or Justin?
Yeah, sure. Like for this one, I think we were talking about personalization for language models basically, and two techniques that we specifically think is being domain specific and contextual understanding. Especially when we talk about legal terms, we have trained model especially towards a particular domain and particular context to answer the questions way better than like a generic language model could answer basically. And to add to that, Justin, do you want to add anything to the legal models?
Just the idea that it's really important to actually evaluate whether you can train these domain-specific models, because you can use a generic model like ChatGPT, but it's going to be much worse than if you actually use your data and it understands the type of information that you're going to be looking for. And the answers that it can provide are going to be much more accurate and much more relevant to you.
So some of the examples, as you can see, we have mentioned MedPalm 2, that's basically for medical questions. So similarly, we are working on legal domain, we are working on compliance standards. So we are trying to get expertise in multiple domains basically and customize the language models to the domain.
So what the graph represents is that performance on a given benchmark task is essentially going to, hopefully improve over time. And that's what you see here in this graph. But what's most interesting about it is that the models keep changing. So there's a lot of update in the field all the time. So it's actually important, even for providers like us, to have the right kind of benchmarking environment to try out these models, because when people are writing academic papers, they don't tell you very much about how useful their models are going to be for practical industrial problems. Okay. So another distinction, stuff like ChatGPT, typically, Alan, did you want to ask a question? Go ahead.
Yeah, thanks, Sanjay. As a lawyer, I was wanting to know then if you need a new model for each case you're handling, or whether you just sort of prepare a model for your area of practice or something like that.
So I did work on a system for predicting case outcomes for appeals on veterans cases in the US. And that was quite interesting because that particular domain, the documents all have a reasonably similar structure. So it's quite good to build a model of them as a collection. But, for an area of practice, there's always going to be specific terminology that's coming up in the actual, circumstances of the case. And so you would want to be, personalizing the system for that. So in the best of all worlds, you have a model for the general area, but then you tune that, for your specific domain. In terms of data privacy, I'm just riffing here on Christina's question. You have to basically, there's two ways that security comes into focus here. One is the process of training the model means that your data is going to be ingested by an algorithm, and clearly you would want that algorithm to be running on your own hardware, and the model being built, stored on your own, internal network, so that the resulting proprietary model wouldn't leak. But there's also a security issue with large language models where you can actually ask them questions and probe them, and they can actually divulge details that they know that you might not want to make public. So, if you ask ChatGPT what my home address was, it might know. I haven't tried, but it might know that kind of thing. So these are really important questions. And I think we always talk with our customers about security. And sometimes we use commodity cloud resources, and sometimes we use, completely protected, proprietary, cloud resources, for doing applications because of that concern.
So really quickly add on this, specifically in our solution, we have several different options depending on how sensitive your data is and what are your kind of like legal obligations about this data. So we have an option where the data never ever leaves your system. So our solution is deployed within your infrastructure. Another option is that only question and answer leaves your system, so that processing is happening on our end, but the original the data always stays again in your infrastructure, and we help set it up. So there are a variety of options specifically for deploying Square, and we always take into account specifics of the customer.
So we should move on to the next slide. Any other questions before we move on to static
We have
Well, Clarissa
have
was
one.
asking about Azure, but I think we can address that at the end. Thanks.
Okay.
So go ahead,
Eric.
Jack.
No, it's okay. We can take the questions later. I was just going on a side.
Okay. Okay. So when we think about where automation of this kind of question answering or information retrieval technology can have the most business value, it turns out that it's not all chatbots and lovely interactions with robots. It's actually performing very repetitive tasks that are done by humans today. So in the sort of financial compliance phase of an accounting firm, you have to look at lots of reports being written by third-party vendors, for example, documenting whether or not they are compliant with the cybersecurity policy. And there's a fixed set of things that must be verified about each set of documentation that is received, and those can be easily formulated in the form of questions. Do all login are all logins protected by an encrypted password file, this kind of thing. And what we found was that it is actually quite efficient to engineer what we call a static approach, or let's say report generation approach, where you can fine-tune a system to answer the same set of questions over and over again, just as well as a human can. And for the variety of tasks that we see here, where this kind of document review is common, like in the research industry, customer support, compliance and legal, standards, human resources, this is a very, very valuable application of question answering. So it's not all chatbots. Sometimes it's a procedure that's going to run a set of background questions for you and generate a report for you, either on demand or at certain preset times. Of course, dynamic question answering is important, especially when you're trying to do decision support, or you want to support somebody who is doing, for example, real-time repair of aircraft. There's a big market for the ability to put lots of technical information into an app where somebody can just converse with it in a speech language interface in order to quickly drill down on the information that they need. And that's not really been the focus of these more social media chatbots, which are focused much more on being able to have a conversation with anybody about anything. You might want to, provide an interface to company internal documents for only your employees and vendors. The question then is how to adapt, existing technology to give you this kind of dynamic, capability, but in your domain. Purvis, you had a question.
Can we unmute him, or Jack give him capabilities to unmute himself? Or
I'm sorry, I was muted. My apologies. Thank you for taking my question. So I guess in regards to static questioning, right? Well, can it be delivered over multiple mediums, or any medium that I choose for it to be delivered over? That would be my first question. And then, is it kind of static questions like, how do, if customer service, how can I pay my bill, right? Or is it in dynamic, comparing static to dynamic would be, can you tell me if I can pay my bill at, X station, or so forth and so on? Like, what would be, like, how would I distinguish that first the medium, and then how would I distinguish really from customer service static between dynamic?
Yeah, so static is mostly when you have, it's kind of like you're doing data mining or data analytics, but you're not, running a MATLAB job over numeric data. You're running the same, natural language queries over documents. So a good example would be every month you take all of the customer reviews that you received on Yelp, and then you run queries like, how many positive reviews mentioned the decor, or something like that, something that you're interested in. So that's kind of what we have in mind, for the static stuff.
Gotcha.
It's to give you like
Gotcha.
regular data points, but data points you can only get, by asking
Gotcha.
a question.
Okay, so this is more so when you say QA, is it QA kind of quality assurance or areas, or is that what does QA mean?
Well,
Question
it's
and
QA for
answering?
QA. It's question answering for quality
Oh,
assurance.
and question answering. Okay. So in that breath, I think it would be the application would be more towards analytics then, and analyzing data as opposed to.
Yeah, I think
Okay.
that's actually a good way of thinking about it, is that static stuff is when you need to have regular reporting, and it's either used for, like you say, data analytics, or maybe strategic decision making. In terms of the delivery, you can get reports in PDF. We've also worked with, Tableau dashboards so that we can use pie
Gotcha.
charts and heat maps and all of that stuff. One of our early applications for Kroll basically processed about 1 million documents a day from the dark web, and then produced a set of reports that were visualized as different charts and dashboards in Tableau. So it can definitely be in different media, depending on what you're interested in.
So, Eric, do you want to quickly talk about Clarissa's question about Azure OpenAI services and data privacy, and or somebody can, and then let's move on to the demo. And
Let's do that.
definitely
I
come back to you.
don't want to run out of time. That's good. Yeah. So Clarissa, I think if you decide you want to use Azure for safe storage, we would just adapt everything that we have to use the Microsoft cloud. From the perspective of technology providers, Google, Microsoft, and AWS are the big three, and we're basically prepared to deploy on any of them. So if you have a particular platform that you're comfortable with, everything that we do is all based on containers and virtual machines, so it can pretty much run on any cloud once we've compiled it to some reference image.
Yep.
Okay, so let's move on to the demo, guys.
We have one more question from the anonymous section. Let's take that before
sure.
we head to the demo. So this is the question I just pasted in the chat. Given that a number of companies be using LLMs to solve for some problem solving with enterprise business, what differentiation can these businesses have?
So that's a great question. I think that if you sort of take away LLMs and think about AI, the companies that always get the benefits are the ones who are ready to move early within their kind of cohort, right? So you have to decide that there is an analytic objective there that you can solve with AI, and then you have to commit to doing what you need to do in your organization to make it happen. I think that what businesses can do with AI is if you literally find out what the most important information is that you can glean, this kind of AI can put that at your fingertips in a way that's really hard to do, just using a search engine, let's say. But to make it worthwhile, it has to be something where there is sort of a recurring need. You're not going to build, a fancy AI solution for, an ad hoc search that you do, once a year in order to, get some statistics for your, yearly report. It's probably still going to be more cost effective to have a human doing that. But if you think about a situation where you're doing mergers and acquisitions and you want to have updated, summary reports from a variety of news sources and public information sources 2 or 3 times a day, it would be a huge task to train and deploy an army of humans doing that, where it would be much more straightforward to do that with software. So probably problems where there's a huge economy of scale in rolling out AI are going to be ones also where there's a big differentiator.
And also you can differentiate based on customizations for a given domain, predefined value add use cases or predefined questions, and your ability to answer that will really help you differentiate from your competitors. With that, I think we should definitely jump into the demo. Jag or Justin, over to you guys.
Yeah, I can share my screen. So as Eric was talking about, it's really important to consider that there are pros and cons to the extractive and the generative technology. So whenever you're searching for information on a set of documents, you want to make sure that that information is correct. You want to understand how the AI got to that answer, because these could be questions that you need to answer correctly in order to make important business decisions. And you can't allow a system to just make things up and for you to act on that incorrect information. And so what we've built at Cognistx is a tool that allows us to combine the fluency of these generative models with the accuracy and the explainability of the extractive systems. And so this is the Square chatbot, which actually allows us to do a combination of those two things. And we can just kind of interact with it like we would any normal chatbot. So we can just, let's make our first query just hello. Cool. So this is Squarey, an AI created by Cognistx. How can I help you? And let's just see that it can kind of interact in a conversational way, if that's what we're looking to do. And it can also understand the kind, it maintains a history of what we're talking about, and it can actually understand. So my name is Justin. Then I can ask, what is my name? And it can still understand that it's got this context to understand what we're currently doing. So now, if I actually want to understand something about some documents, I can ask more information-seeking queries to the chatbot. And so the documents that we currently have loaded in here are about YPO. And we'll just let the chatbot kind of explain what that is. So tell me about YPO. So it's a global platform for chief executives to engage, learn, and grow. And so that's a great answer. It sounds fluent, sounds promising, but what we can actually do is look at the sources for how the AI came to that answer. And we see that it actually pulled from 4 different websites that we had previously ingested to be able to answer this question appropriately. And we can actually go into those and see kind of where it came up with these specific verbs. So the other really valuable aspect to this chatbot format is that because we have this context in the chatbot, we can ask questions like, how many chief executives does it have? And so we aren't mentioning YPO as an organization directly, but the AI knows that it refers to YPO because that was our previous question. So let's ask this. And immediately, it's able to understand that it refers to YPO and again, provide us sources for where it found that information. So let's keep going. Again, what is its highest elected office? It's able to understand that we are again looking for YPO and we're trying to look for the highest elected office in that organization. Come on. So now this time it's able to understand that 1 doesn't refer necessarily to the chairman, but might just be a member, or I guess in this case, it is looking for the chairman. Cool. So the AI is also smart enough to understand that if we're no longer looking for information about YPO, it'll be able to adapt and switch to the conversational approach again. So how are you doing? It understands that it doesn't need to provide sources for something like this. I'm not actually looking for any kind of information. I can even ask it to tell me a joke. So started telling jokes about robots. Fun.
We do not guarantee that the joke will be funny.
Yeah. But then if we switch back to looking for additional information, so this is a project specific to this organization, we can ask it to understand why this project might be important. And so we see that it provides information about the project itself and understands to provide us with actual impacts that this project has. So it's able to generate an average of this many gold certified credits, and it's able to partner with local village communities. So it gives us a response that actually provides some relevant information for this question. Now, if we say, tell me about its creator, it understands that we are referring specifically to this project, and we're looking for that creator. So Desarno. And finally, we can ask, did he get any awards? So we see that he received the YPO Global Impact Award. And let's just look at one of these sources quickly to kind of understand how it's coming to these conclusions. And we see that it's able to look at all of these websites and pick out that it has named this person as the award recipient. And so we're able to see that it finds this information in these PDFs that contain lots of different text.
PDFs or URLs?
Yeah, PDFs, URLs, any kind of place that would store some kind of information.
Justin, there's a question also. I don't know if you saw that. I know you're giving the demo.
Let me look. What LLM was used to develop this demo? So the idea is that we are actually combining the generative and the extractive approaches. And so there's actually multiple language models used in this kind of system. So the extractive part of this is our system called Square, which is our scalable question answering system. And it's able to actually go into these documents and find the exact pieces of information that are needed to answer that question. And then the generative aspects of this are language models that are much more similar to the ones that are used by like ChatGPT. And so they're able to take the information that we've found using Square that might contain the information needed to answer the question, and then it's able to craft an answer that might say something like yes, and then actually tell us what the answer is.
So I think a key also point here is you need to sort of think about the use cases, think what answers you want, what interface you want, and then put the models together, both extractive and generative, to sort of come up with the best answer. And if it's domain specific, if all your questions are going to be legal domain or YPO in this case, or medical domain, then train the models, the generative and the extractive models on those, and sort of, get the best of both worlds that way.
Mm-hmm. So the last thing that I wanted to show in this demonstration is that we're not necessarily limited to this kind of strict interface here with the chatbot and having to go to a specific website to type in these kind of queries, but we can actually deploy these systems already in kind of your existing business infrastructure. And so one thing that we have at our company is Slack. And so it's actually very easy to integrate these kind of systems directly into Slack itself. And so we see right now I'm moved to our Slack and I'm actually conversing with this model in the form of a bot. And if I send it a direct message, like when was IPO founded, it's able to look at that information and it's able to query that and even include the sources directly here as well. And so basically, we want to make this kind of technology as easy as possible to deploy and for employees to actually use. So if you're, say, looking at answering questions over internal documents that your company might be using, then you can actually just message a bot directly in your Slack and ask for those that type of information. And it can give you not only an answer, but also sources. So it can point you to the exact URLs or the exact documents where you might need to be finding that information. And that way you can find it very quickly. You can go directly to it all without even leaving the existing messaging services that you're using. So I think there might be some questions, maybe not.
Again, any questions, do let us know. Again, Justin, Igor, Jag, the team, awesome job with the presentation. So thank you for that great demo, and we'll again open it up for questions.
So we do have a question. What if there are different sets of documents, internal and current customer data?
Eric, I think you're talking, but you're muted.
Thank you, Cody. So typically in academic model building, people just have one corpus and they build one model, but there's nothing to prevent you from building different models for different resources, and then having the system reason about which resources to use. So you might want to sort of think first about the question and then decide where to look for the information. So if that's how you think of the requirements for your domain, it would be no problem for us, to set something up that way. In fact, it's fairly easy for us to build a query bot for each domain that you have, and then we can have a bot that interacts with all three of them to find out where the best answer might be. So if that's how you perceive the data, no problem. Yeah.
I just wanted to add, actually something that query supports is an option to decide which data set to use. Again, you have like single kind of application that you query, but depending on your question, depending on the previous context, it will be able to decide which domain to ask this question on.
Just to add, how can one get started with us on Square? Feel free to connect with any of us through any channels. We have our website as well. So you can connect with any of us, send an email to us, or hit me on LinkedIn, basically. We also provide I think that email ID is wrong, but yeah, it is this. If someone wants to just copy it, you can connect with me. And we generally, feel free to share your documents or any sample data that you would like Square to kind of come on. And we'll show a demo, a sample POC basically to see how the Square is doing on your documents.
Any other question? Okay, without disclosing any, can you please tell me ideal customer profile? So let me sort of answer that. So both profiles are good. We could actually work with larger companies, but ideally sort of, mid-market sort of, companies between 200 million to 10 billion in revenue would fit very well because they are not being handled by the big boys. Sort of, we can take your documents, we can understand the queries, we can understand users of those documents as to what questions they have. Should it be extractive? Should be a combination of extractive and generative? What can already be answered sort of in terms of FAQs or predefined questions, so that you get the best results possible. Obviously, customizing for your given domain and your set of documents, you will get the best precision or sort of accuracy from an answering perspective.
An ideal customer is also one that realizes that AI isn't just an off-the-shelf technology that you buy like a home network where you're going to come home and install it and everything is going to work. It involves a certain amount of customization. And while we are ready to do that, you have to be ready to engage with us. So it's great if you have somebody on your side that's going to be the AI rainmaker, let's say, within your organization, because during that 3-month period, we definitely need somebody who's going to be the right conduit, so that we get the right information and requirements, and who's going to be a champion, for the technology within the organization.
I would just add from the privacy perspective that we do cater to any privacy requirements and let the data stay put in the environment that you would need to get started with Square.
Again, thank you everybody for joining. And if you have any questions, feel free to reach out to us. You can even reach out to Cody. I'll let Cody introduce himself, give his email, or Jag, so sort of, and we'd love to talk to you about your needs, even explain to you what generative or extractive models can do for you.
Excellent. Yeah, I'm Cody. I'm the business development executive here at Cognistx. And so I'll put my name in the chat, but for everyone who came in today, I'm going to call you, see what's going on, see what questions we can answer. But in all seriousness, I think that's what helps set Cognistx apart. Is the size of our company is we want to get to know you. We're not just some plug and play solution. We want to know what are your custom problems. and how can our AI fit into that? And we take those calls seriously through that exploration to make sure we can attack your specific pain points.
Great. Thank you, everybody.
Bye-bye.